Okay guys, this is chapter 5 part 3, multiple alternatives. So we looked at if statements and if else statements. Well, there's something called if-elseif statements. So you can test for more than one condition. You can test for multiple conditions. And so here's the format for it. If condition 1 is true, then it'll execute statement 1. Else if condition 2 is true, then it'll execute statement 2. And if both of those are false, then it'll drop down to the else statement. Then it will execute statement 4. So you can have lots of different conditions here as part of the same if statement if you use if-elseif block. So the first matching condition is executed. So if condition 1 is true, it'll execute statement 1 and end. If the second condition is true, it'll execute statement 2 and then end, and so forth. Order does matter with your if-elseif statements, and this is called if ladder. So if Richter is greater than or equal to 0, this is always true because Richter is going to be a positive number, so it'll always display generally not felt by people. So this will not execute correctly. So the order does matter with your if-elseif statements. Don't omit else when you're dealing with if-elseif blocks. So if you just say if Richter greater than or equal to 8, and then you have if Richter greater than or equal to 7, well, these are two separate if statements if you don't include the else in front of this if. Okay, if you want it to be all part of the same if-else block, you have to say if some condition, else if another condition, else if another condition, like that. Okay, so don't forget about the else. Here's an earthquake example. Here you have your class, a class that describes effects on earthquake, public class, and then earthquake, that's the name of your class. And then inside the body of the class, you're going to have your instance variable, okay, private, you want to make your instance variables private. Double is the type, and then Richter is the name of the instance variable, okay, and that's just characteristics of an object created from the earthquake class. Then you have your constructor, and we know constructors initialize instance variables. So here we have public earthquake. Okay, constructors don't have a return type, so it's just public and then the name of the constructor, which is the same name as the class. And then we have our parameter variables, double magnitude. Okay, so magnitude is being passed in as a value, and so magnitude is assigned to Richter. So now our Richter instance variable is going to have a value, it's initialized to a value that's passed in called magnitude. And then we have a method called getDescription, and it's going to return a string type. So it gets a description of the effect of the earthquake. So in our getDescription method, we have a variable r of string type. So we say if the Richter value, that is our instance variable, if the Richter is greater than or equal to 0, then it'll display most, or it will assign r to most structures fall. Okay, our variable r. Else if the Richter is greater than or equal to 7. So this means if it's greater than or equal to 7 and less than 8, okay, because it doesn't, that means that this was false, so it's greater than or equal to 7 but less than 8, many buildings destroyed will be the value of r. Else if Richter is greater than or equal to 7 and less than 8, because this was false and this was false, so we know it's greater than or equal to 7 less than 8, then it'll display that, and so forth, all the way down to the else. So if it's not a positive number, it will go down to the else. And then at the very end of our if block, we're going to end the if and then return r. Okay, so that will be returned from this method. Okay, so now we need to test out our earthquake class with a runner class or tester. So first thing we're going to do is import scanner, because we're reading in a value. Okay, so we've got to import the scanner class. Then we have public class earthquake runner or tester. Then we have our main method header, public static void main string args. We create a scanner object because we're reading in a value from the user. And then we're going to print, enter a magnitude on the Richter scale. The user is going to enter a value that gets read in as a double type and assigned to magnitude variable. That's a double type. And then we're going to create an earthquake object called quake. And we're going to pass the magnitude that was read in to the class through the constructor, and then we're going to have that quake object variable. So then we're going to take the quake object variable and invoke getDescription on it, so then it'll return a description based on the magnitude value. that's passed in through the constructor. So here's a example run here. Enter magnitude on the Richter scale. If they enter 7.1, then that will actually execute this portion of the if-else block. So many buildings destroyed will be assigned to R, and that will be returned from that method. So many buildings destroyed will be displayed to the user. Okay, there's other types of if blocks that are a little bit more complex that allow you to do other things. So there's something called nested if statements. So you can have if statement inside of if statement. So a branch inside another branch. So you can have if condition 1. So if that's true, then it'll go inside the body of the if, and it'll look at this other if statement. If condition 1a is true, then it'll execute statement 1a. Otherwise, it'll execute statement 1b. Okay, so if this condition is false, it'll go down to the else, and then it'll execute this statement 2. Okay, so here's an example, a text schedule example where you could use your nested if statements. So if your filing status is single, and this is for paying taxes to the government, so if you're single and your income level is between 0 and 32,000, then the tax you'll have to pay is 10%. So you have to pay 10% of your salary or income to the government. If the amount of your income is greater than 32,000, so if you make like 33,000, then you'd have to pay 33,000, 34,000. Anything over 32,000, you have to pay 25% of your income. If your filing status is married, that's different. The tax bracket is different. So if your income is between 0 and 64,000, your tax rate is 10%. If you make over 64,000, your tax rate is 25%. So nested branches, so compute taxes due. So that's what the program is going to do, given the filing status and income figure. So are you married or single? Is the filing status and income, do you make 32,000 or higher? If you're single, do you make 64,000 or higher if you are married? So you need a branch on the filing status, and you need a branch for each filing status, a branch on the income level. The two-level decision process reflected in two levels of if statements. We said the income test is nested inside the test for filing status. So here is a flow chart to show all the branches of the ifs. So if you're single, okay, so if that's true, then is your income level less than or equal to 32,000? If it is, then you're in the 10% bracket. If that's false, okay, if you make more than 32,000, then your tax bracket is 25%. Okay, and if you go back up here, and single, if single's false, if they're married, then you go down this path. Is their income less than or equal to 64,000? Then they're in a 10% bracket. If their income is greater than 64,000, they're in a 25% bracket. Okay, so that's how that looks as a flow chart. So here is the class for the tax rate. It's called tax return. And in our tax return class, we have a couple of public static constants. Okay, so these are public because these are variables that are just belong to the class itself, so we're not worried about somebody changing them, and they are constant, so we can make them public. And we have single equal 1, and note that your constants are typically all uppercase letters, your constant variable names, and married's 2. And then you have your constant rate values. These are values that are more important in terms of payments, paying money to the government, so we're going to make those private. Okay, we're going to be more protective of these values. So rate 1 is 10%, rate 2 is 25%. Okay, and then there's rate 1 single limit. Okay, the limit for the income is 32,000 versus the rate 1 married limit is 64,000. Okay, now here are instance variables. Okay, and private double income and private int status. Okay, now we have a constructor, and this is public tax return. Remember, the constructor name is same name as a class. Then we have our two parameter variables, income and status, and we need those values in order to determine the tax rate. And we have our parameter variables that then get assigned to instance variables. And then we have our get tax method that will actually determine the tax rate. And so we're going to initialize two variables to 0, local variables. Okay, they're declared inside the method, so they're local variables. Initialize those to 0. And now we have our if block. So we have if status is single, if they're single. And then if that's true, then we go in here and look at this if block. If the income that they're making is less than or equal to the single limit, which is $32,000, then their tax amount is the rate. Okay, and that's that 10% times their income. Otherwise, their income is greater than $32,000, so their tax 1 amount is the rate, which is that 10% times the single limit, which is $32,000. Plus the tax 2, which is the rate 2, which is a 25% times any income over $32,000. Okay, so if they made $33,000, this would be $1,000. Okay, so anything over $32,000, they have to pay 25% on that. Okay, so now that's that first part of the if, and so the second part is the else. So if this was false, then they're married. So if the income is less than or equal to the married limit of $64,000, then it's the rate, which is 10% times their income is the tax amount. Otherwise, the tax 1 equal to the rate 1, which is 10% times 64,000, and plus the tax 2, which is the rate 2, which is 25% times any income over 64,000. Okay, so essentially after the if statement is executed, we're going to turn tax 1 plus tax 2. Okay, so that's the total amount of tax they have to pay. So here is the tester, and again we import scanner class because we're reading in values from the user, and this is just a tax collector. We have our main method, we create our scanner in object, then we read in the income level, okay, and assign it to income variable, read in are they married, okay, read that in, assign it to a string variable, and then we have we declare a variable status as int type. And if what they entered as their marital status, if it's Y for yes they're married, and we don't care about the case, it could be uppercase Y or lowercase y, then we say tax return dot married. Okay, which was up here. Married is, let's see, married is 2. So that'll be the value of 2. So that's the value of 2, so status will be 2. Otherwise, the status will be 1. And then we're going to create a tax return object. And we're going to pass in the income and the status that we read in. And then we're going to print the tax amount. So we're going to take that tax return object and return get tax on it. So if their income is $50,000 and they're not married, then the amount of tax they have to pay is $11,211.50. Okay. Okay, so I'm going to end this part of the screencast, and I will continue with part 4 after this.